In this section, we're going to be solving exponential and log equations. These can be very basic, but to solve or get rid of the log or the exponential, but then they might turn to a quadratic, so you have to use quadratic formulas. So they can be very weird. So we're going to first start with the easy ones. So we're going to solve with a single log. So we're going to do first the logarithms, and then we'll do the exponential. So what about if you only have one log? So if you have only one log, all you want to do is just convert to exponential. Okay, that's really what you want to do, because you really want to get rid of the log. That's the basic thing that you really want to do, because one log is hard enough to figure out. So and also what you want to do is just check for negative values, because sometimes remember that the log cannot get negative vibes. It only wants positive vibes. Okay, so let's just jump right in and just start solving a couple of them. So let's say we had log base 2 of x is equal to 3. Okay, so one of the first things that you want to do, let's just convert it to exponential. So I'm going to take this 2, I'm going to bring it around. So it's going to be 2 to the third equals x. So 2 to the third power is equal to x. So this is going to be really easy, because now you're basically solving it, which is x is equal to 8. Okay, so x is equal to 8 in this case. That's the answer. All right, so now that I have the answer, I can just plug it back in there, and you can see that it actually makes sense. And you can use a change of base formula, or you can use your calculator to make sure that log base 2 of 8 is actually equal to 3. Okay, all right, let's do another one. So let's say we have part B, log of x is equal to 2. All right, so now notice we don't have a base, but we know what this base is. If there's no base, that means it's base 10. So you're going to have 10 to the second power is equal to x. So x in this case is equal to 100. That is my answer. Okay, see, they're not too bad, not too terrible. Okay, now sometimes you're going to have problems where you're going to have something in front of the log. So something that looks like this. Well, not a problem. All you got to do is just isolate this log, divide it by 3. So get rid of that 3. So you have ln of x is equal to 1. Okay, now remember ln of x, what kind of base does that one have? That one has base e. So you're going to take e, raise it. So you're going to have e to the first power is equal to x. So basically x equals e. You don't need to write 2.71, just leave it as e. Okay? All right. So now let's do some other types of problems. Okay, because this is with a single log. A single log is not too terrible. Always check for negative values. That's really what you want to do. So let's try this. Let's try one more. B, C, D. Log base 2 of x squared is equal to 2. Okay. All right, so now I'm going to do the same thing. Swirl it around. So it's going to be 2 to the second power equals x squared. Okay. 2 squared is going to give me 4, which gives me x squared. Take the square root to both sides, but when we add square root, you also want to add plus or minus. So x equals plus or minus 2. Okay, now let's check, because always a negative one, we have to be very careful that there only is positive vibes. I plug in 2 in here. 2 squared is going to give me a positive 4. Plug in negative 2 squared is going to give me also a positive 4. Okay, so that one checks out. Now, alternatively, one of the things that you could have done, you could have done the following thing. Log base 2 of x squared equals 2. You could have bring this 2 to the front. You have 2 log 2 of x equals 2. Divided the 2 over, so you have log base 2 of x equals 1, and then solve it that way. So that's another way that you could have done it. Okay. All right, so now let's do a couple more problems, but now we're going to do problems when there's 2 logs on one side. Okay, so how are we going to do that? So solving when you have 2 logs on one side. Okay, so how do you deal with 2 logs? So I only had 1 before. Now what about if I had 2? So what you really want to do is use properties, okay, to condense into a single log. So if you really need to, if you have two logs in one side, all you want to do is just condense it into one. Okay, this one you really want to check. Make sure that you really check, because sometimes these can be really not correct. So let me give you an example of where you should really check. So let's say you had log base 3 of x plus log base 3 of x minus 8 equals 2. Okay, so you have 2 logs. Okay, so what are you going to do? Well, let's go ahead and condense it into a single log. So there's an addition sign, so this is going to turn into multiplication. So you're going to have log base 3 of x times x minus 8 equals 2. Okay, and now that I have a single log, now I can convert it to exponential, just like how we had it in the first place. So I'm going to convert it to exponential. So this is going to be 3 squared is equal to x times x minus 8. Okay, I'm going to distribute this x. So I'm going to have 9 is equal to x squared minus 8x. And now I have a quadratic equation. So now we converted a log to now a quadratic. So now let's solve for this. Remember, when we have quadratics, we have 2 x's here. We want to set them equal to 0. So I'm going to minus the 9 to the other side. Okay, so I'm going to have 0 is equal to x squared minus 8x minus 9. Okay, and now at this point, what you want to do is just factor this. Or you can use quadratic formula if you'd like. But I think factoring would be faster. This should be a 9. This should be a 1. This one should be a minus, and this should be a plus. So now we're going to break them up into 2. X minus 9 equals 0. X plus 1 equals 0. So here we're going to get x equals positive 9 and x equals negative 1. Okay, now are both of these going to be solutions? Well, let's just double check. Let's plug in the 9. Okay, so when I plug in the 9 is here. So this is positive. This is good. I'm going to plug in the 9 here. 9 minus 8. This is positive. It's still good. Now what happens when I plug in this negative 1? Well, when I plug in the negative 1 here, oh, this is negative. So it's not going to be a solution, because the log 3 of a negative 1 is going to give you an error in the calculator, and you can try that out. Okay, so the negative 1 is not a solution. It's just x equals 9. So you always want to check this. Okay, and you'll find them because you're solving a quadratic, and the quadratic doesn't know that initially it was a log. Okay, all right, so let's try other problems. So let's try this one. So let's say we had the log base 2 of x plus the log base 2 of x minus 2 equals 3. So try it out if you want, and then you can double check with me. All right, so I see an addition. I see 2 logs. Let's combine them. It's going to be log base 2 of x minus 2 equals 3. Okay, so I combined them. Then I'm going to go ahead and circle around. So I'm going to have 2 cubed equals x minus 2. 2 cubed is going to give me 8. I'm going to distribute this out. X squared minus 2x. So now I'm going to minus the 8 to the other side so that I have all of that. So 0 is equal to x squared minus 2x minus 8. All right, and now let's factor this out. X and x. So 2 numbers are multiplied to get negative 8 and add up to get negative 2. That's going to give me a 4 and a 2. Okay, so this is going to give me negative. This should be positive. So my answers are going to be x equals negative 2 and x equals positive 4. I can tell you right now, x equals positive 4 is going to be okay. This one's going to be not okay, because when you plug it in here, you're not going to get the right answer. Okay, and same thing on the other one. All right, so now let's deal with problems like this one. So let's do one more of these. before we get to the third case. So let's say we have 3 log x minus log of 125 equals 0. Okay, so here let's try to combine the logs because I see 2 logs, but before we combine them, notice that there's a 3 there. So I should probably do something with this 3. So let's bring it back to the top. So it'll be log x to the third power minus log 125 equals 0. Okay, so now I can combine them. There's a subtraction there, so now this is going to be division. Log x cubed over 125 equals 0. All right, so now let's circle this around. We know that this is base 10, so it'll be 10 to the 0 is equal to x cubed over 125. Okay, 10 to the 0 equals 1. X cubed over 125. Then what I can do to solve this, I can multiply both sides by 125. This one will cancel here. So I'm left with x cubed is equal to 125. And the last thing I want to do, how do I get rid of that cubed? Well, I just cubed root both sides. So x is going to be equal to, the cubed root of 125 is going to be equal to 5. Okay. And all you got to do is just plug this 5 back in there and you'll see that it gives some positive vibes, so it's all good. Okay, so now finally we're going to do the last case with these logs. And this last case is going to be when you have logs on both sides. Now, one thing that you can do is you can easily bring one log to the other side and treat it as if you had two logs on one side. But what I think this might be a little bit easier when you have log and a log. So this is what we call a 1-to-1 property. Because we know that this is 1-to-1, we can say the following thing. If the log of a of m is equal to the log of a of n. So notice the logs are the same, the bases are the same, so what does that tell me? If the logs are the same, that means that the arguments, the thing inside of them, are also the same. Okay, assuming that n is greater than 0, m is also greater than 0, a has to be greater than 1, and a is not equal to 1. Okay, so all that blah, 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 blah. Okay, so let me just give you a couple of examples of what that might look like. So let's say we had log of 49 equals log of x squared. Okay, so remember, because we have logs on both sides, if the logs are the same, that means that the arguments are also the same. So that means 49 equals x squared. So basically we can kind of, if you can think about it, we can kind of cancel the logs out, but don't think about it that way. But that's what we have. So now all we got to do is just take the square root to both sides. So when I add a square root, I also add plus or minus. So x is going to be equal to plus or minus 7. And they're both solutions. You can check them. Okay. Let's try a couple more. So let's say you have the log of 3 of x squared plus 3 equals the log of 3 of 4x. Okay, so notice the logs are the same, so that means the arguments are also going to be the same. So this is going to be equal to this. So x squared plus 3 is going to be equal to 4x. We have another quadratic. Let's move the 4x to the other side. So you're going to have x squared minus 4x plus 3 is equal to 0. We can factor again. X and x, 3 and 1. And in this case, they both should be negative. So we're going to get x equals 3 and x equals 1. And luckily, they are both solutions as well. Okay. And then we'll do one more problem. B, C, D. So we'll do this problem. So we'll say log of 9 of x plus log of 9 of x minus 4 equals log of 9 of 12. Okay, so the first thing that you want to do is we know that the logs are the same. So all of them are the same, so let's not equal them yet. Okay, we need to combine them so that a log equals a log. Because if you look at the one-to-one property, you have a log has to equal another log. Not a log plus another log equals another log. It has to be one log equals another log. So let's combine this. So this is going to be addition. So this is going to be multiplication. Log of 9 x minus 4 equals log of 9 of 12. So now, because the logs is equal to another log, that means the insides are going to be equal to each other. Okay, so we're going to have x minus 4 equals 12. Distribute this out. X squared minus 4x equals 12. I'm going to move the 12 over. So I'm going to have x squared minus 4x minus 12 is equal to 0. Okay, and now let's factor this out. So you're going to have a 6, 2 and a 2 there. So now in this case, this is going to be a negative and this is going to be a positive. So x is going to be equal to 6 and x is going to be equal to negative 2. So let's check both of them. Okay, so 6 checks out, but the negative 2 doesn't, because the negative 2 is going to fail here. You're going to get a negative number, so that's not going to be a solution. So my answer is just going to be x equals 6. All right. Okay.